Voice audible? Just 1 minute. Voice audible? Clearly? I got little settings here, no problem. Is the voice audible? Wait, no reply. Oh, wait, one is one. Okay. One minute. Little time. Question is here. This is a given beam. You start and find reactions. Already told last time. See, I have given the first question in words here. I put the mic on. First question given in here. Sketch given. From there, you come here and find the reactions. Which one? MA and VA. I start in 2 minutes. Okay. I will go for setting. I not move the camera. I move the camera. Right line left. Okay. Fully visible, correct? Now fully visible. And this question solved systematically. It is simple question, no doubt, but this will contain lot of concept. I will explain one by one. It is not, actually this will take not more than 2 minutes. If you only want the diagram, not more than 2 minutes. See, first I start the question, you write a heading there. We are starting SFD&BMD for cantilever. Again make a note, one side fixed, one side free. It hardly matters which side fixed, which side free. See, so because if I take cantilever like this here, this side fixed, somebody on the back side, he will tell other way. What he will tell? See, whatever you take here, back side person, if he looks, he will tell, see, you are telling left side fixed, right side free. Person who is the back side, he will tell right side fixed. You tell clockwise moment. he will tell anti-clockwise moment. Shear, you tell left up, right down. For him it will become what? Right down, left up. No, right up, left down. And bending moment, for you also sagging, hogging, for him also sagging, hogging. Upward, downward, for you also upward, downward, he also upward, downward, he or she. Someone will tell, you have not told us. Okay, then, see the question. A cantilever beam of length 9 meter. There is a cantilever of 9 meter length. Some will tell 9 meter. So what? I will take 9 kilometer also. My wish. I don't want small numbers here. Usually cantilever will be how much? 1 meter, 1.5 meter like that. If I take that way, I have to give changes here. First question, I want a clean answer. So what? 9 meter. It is not told in the question whether left side is fixed, right side is fixed. So you make a note. It is hardly matters, but you decide. Do not waste time. Shall I take left fix or right fix? Don't waste time. Decide fast. Usually in India, when they tell cantilever, tendency is to write this way. But so many Indian authors, they write this way also. No problem. Okay. You make a note. We will solve the question in the front view here. Left side fixed, right side free. Now do one thing. See, loading given. UDL of 8 kN per meter over entire length. So, whether you take left side fixed or right side fixed, UDL has no problem. Then, 3 point loads of magnitude 30, 40 and 60. Where? At the free end. First load at the free end. Second load at 4 meter from free end. Last load at 2 meter from fixed end. This is the correct procedure. Even who is looking from that side, suppose you write this way sketch. See, because why? He will write this way. For you same. Then also, what he will do? He will put the sketch like this. See? He will put UDL here. He will put 30 here. He will put 40 here and 60 here. So, answer is correct. But I have seen so many university papers. That is a little nonsense question. They will tell cantilever of length. First of all, what people do is, to avoid confusion, they give sketch. When sketch given, there is no problem. But when they give words, they should have sense, common sense. Sense means common sense. See, suppose this question, somebody gives by words, he will tell a cantilever of length 9 meter is loaded by UDL of 8 kN per meter or entire length and 3 loads of 30, 40 and 60 at right end, at 40 meter from right end and 2 meter from left end, then he is in trouble, because I will solve the question by taking this way and then this 40 at 4 here, I will take 4 here. Completely wrong. Then he will tell, no, I want right side free, left side fixed. Then I will tell, then tell it. Otherwise, you refer location with respect to free and fixed end. Then anybody who will write the cantilever like this or like this, answer will be same. So when you give a question for simply supported, no problem. Simply supported, no problem. But cantilever or propped cantilever, again same problem. Fixed beam, no problem. Both are same type. When the two ends are having different support conditions, you should mention clearly. If he wants to tell at right end, at 4 from right end and 2 from left end, before that he should tell a cantilever of length 9 meter is fixed at its left end. If that much common sense is not there, I am writing examination deliberately, I will put other way and contest it. I will go to court. Court means what? I will argue why I want court. I will argue. Then he will tell, no, usually. Don't tell usually. When you give a question, give crystal clear idea. So that two persons should have same answer. Okay, now. Question clear? Fast. Question clear or not? Where is the mobile? Where is my chat mobile? Where I kept it? I was having in the hand. I did it. You have not answered. Is the question fully clear? No. Is the question fully clear? Yes. Now, see now, in correct order you have to go. Don't go random order. Solve systematically. Here space problem, I will write some order, but how I explain, go in the same order. Same thing. If I want red color, emergency, I won't get it. When I do not want it, it will be lying somewhere here. 1 minute. Yes, got it. Luckily got it. See, now, after the, see, do not write anything in this sketch. This is the given beam. Okay, leave it. Now you solve this beam. Start. Go there. Go where? Not go there. You come down. Here, come here. Don't see that one. Come here. Calculation of support reaction at the fixed end A. Put one more sketch. Now, support reaction, I will not explain why last class was not for fun. Last class, introduction class, it is not a time pass class. So, loading down, I will assume vertical reaction up, VA. The loading will create about fixed end a clockwise moment, balancing, I will assume anti-clockwise, MA. Okay, now, right here, let VA be the vertical reaction and MA be the reacting moment at the fixed support A. Then further, we will assume vertical reaction VA to be upwards and reacting moment MA to be anti-clockwise. You can write the reason why. Sometimes reason not required because democratic country, even dictatorship country also same answer. See, democratic country, even if you go to some other country like North Korea, there also he can't change the reaction. But what you do is, it is your choice. But see, suppose you take MA clockwise, how ugly it looks. This load will rotate clockwise. Suppose someone is here, somebody is turning here, you also turn there. What will happen? It will spoil the equilibrium. But no problem. In case you consider wrong direction, you are going to get negative. I already told you, the sign you are going to get here has nothing to do with the sign convention used, whether assumed directions are correct or not. Your MA will come plus 914 kilonewton meter and VA will come plus 202 kilonewton. This you have to get referring to previous class. Suppose somebody is new today and not gone through previous class, then go there. Go there and come back. Don't tell me these things all. Okay. Correctly. Got the reactions? Got the reactions or not? Reactions correct? You already told the answer. Okay, done. Anyway, I will tell here, next time onwards, unless something special is there, I will not waste time on reactions. Agreed? I will not waste time writing reactions. I will put the beam, I will tell magic. Find the reaction, then come here. Okay. Clear? Next time onwards, I won't waste time for finding reactions. Okay. Now, anyway, this question. Take moment about A. Put finger here. Clockwise positive. 30 into 9. Clockwise positive. 40 into 5. That also clockwise positive. 60 into 2. That also clockwise positive. 8 into 9 is the total load into 9 by 2. That also clockwise. Your reaction means what? Equilibrium. Full beam you have to see. Yeah, you should see here. Sorry. Then minus MA equal to 0. MA will come plus 914. Sigma V0, if I explain, you should tell it is insulting. Therefore, get MAVA. Okay, now, make a note. We got reactions. Now, full board I will rub. Everything I am removing. Because why? Now, everything is clear. Now, start the concept. Okay, this also I am removing. Okay, 1 minute. Now, right here. Now, go for SFD and BMD. Okay, where? Go here. Come here. Draw a neat sketch of the beam. Okay, then double line I am showing. In this series, I am usually showing double line because I don't want the beam to look like a line. That is my choice. Okay, start. mark the UDL, and one more thing, enter cut distances. This is 9, this is 2, this is 4, so this will become 3. If not clear, right now you can leave the class and change engineering and go to what? Art, science and... no, I am not telling that it's wrong. Go to a subject where mathematics is not coming. Okay. Now, I will call the point as A, already called. This B, already called. I will name this point C, this point D. Over. See, actually C is here, D is here. Now, enter the reaction. We consider VA upward, plus came. Enter upward 2 not 2. No plus now. We considered MA in anti-clockwise direction. Sometimes people will tell, sir, you to clockwise positive. Keep quiet. Do not tell sign convention. It has no effect. I considered anti-clockwise. I got positive. This positive means what you assumed is correct. Enter anti-clockwise of 914 kilonewton meter. Now, this complete force system is in. What? Tell me. This complete force system is in. What? This complete force system, action, reaction together is in. This complete force system, action, reaction together, those given loading with the 3 UDL and point load and the 2 reactions at the fixed end, beam is in equilibrium. Only when the beam is in equilibrium, then you go for SFD and BMD. But one note, for cantilever, you can draw SFD BMD without finding reactions. I will tell you little later. But you should make a note, just because you are not finding reactions does not mean that reaction is not there. Reaction is there, we are not finding. I will tell you after this question is over. Okay, start. Now, everything I am removing now, fresh now. See, first make a note. Okay, ready. Now, beam is ready, below project the points. Light line project. This is for SFD BMD. I will see up to where I can project. See, some scale required. If you mark the dimension values without scale, then it will look what? Horrible diagram. Sometime what will happen is, if proper scale is not maintained, it looks very ugly. Very ugly means, see, you write this is 20 and write this is somewhere a 20, then here you write 80. What? Suppose you write 20 here and 80 here, see, 20, 20, 40, 60, 80. And sometimes I have seen people writing, see, these 2 meter, 2 meter, 3 meter, 4 meter. If you do all this mischief, your diagram will be spoiled. Correct shape will not come. You maintain some, not that you measure. See, 2, 2, 3, 2 plus 2, 4. Maintain some reasonable scale, and when you plot the values, maintain relative scale. That will give you perfect idea. 90% of people, what they do is, as they start here bending moment all, when they reach here, they will reach only half the maximum bending moment. Their maximum space is utilized. Then slightly they go further, they will write 100 here. When they reach here, space this much only is there, they will write 250 here. See how odd it looks. It will spoil the diagram. So that's why I will tell you later how to mark. Okay, start. Draw the baseline for shearing post diagram. This is baseline for shear post diagram. All values are kilonewton. Our sign is left up, right down, positive. Now, one very important. I will make a note. First, I will draw SFD BMD in the traditional way. Traditional means what? How we are doing SFD BMD from class number 1. That way. Then I will tell you something special for cantilever. Not now. Those who want to only, those who are having academic interest, you study only first part. Second part, don't try. Those who want to have good knowledge, how a cantilever behaves, how the behavior is there, for them, after finishing this one, I will go to alternate approach. That is the correct approach. For a practical engineer or for a person who is interested in knowing the subject. or for feeling of the which one. Only academic means what I wrote here is correct. Okay, start. Shear force calculation. See, since I am doing, you write here, first, both the calculations are traditional. Traditional. Traditional is ಕನ್ನಡದಲ್ಲಿ ಎಂದಿನಂತೆ, ಹಿಂದಿ ಹಮೇಶಾ ಕಿ ತರಫ್, English traditional, as you are doing from beginning, or as if you are solving academic question. Start. Come to A, shear force, only force. Come to A. 1000 times I told, extreme end, come slightly inside. Look this side. Shear force at A. Do not tell just to left of A, just to right of A, because extreme end. Some people have seen, they write shear force at A, just to left of A is 0. Beautiful. They finally tell, see shear force diagram, they start from here. When they come here, finally they will get here 202, then they will tell, then down 202 means finally shear force here becomes 0. What a beautiful concept. They should be awarded PhD for that concept. Because just to left of A, there is nothing. Just to right of B, there is nothing. So I told you that twice calculation, shear force twice under a point load and bending moment twice under a couple is only for interior points. Extreme ends, all you have to do is come micro millimeter inside. Okay, start. Look this side. Plus 202. Anybody not clear? My answer is leave my class. This I am doing from more than 110 classes. Tell yes or no. This class number is 100. I don't know, count now. I don't today's class number. If I see, I can make out there. It is more than 110. Clear? Shear force. Just to come to right of A, don't write here. You tell shear force at A, extreme end, come slightly inside. Look this side. Plus 202. Correct or not? If you tell yes means, I will finish fast. Why? Usual calculation. You tell yes is sufficient. I will finish everything. No point in wasting time. Traditional calculation, no point in wasting time. Why? Usual. Endinante. Hamesha ki taraf. Yes. Okay. Start. Come to C. Make a note. At C, there is a point load, shear force calculation twice. First, shear force just to left of C. Copy the previous answer, 202. After A till C, downward of 8 into 2. Subtract that one. Plus 186. Then, come to just to right of C. Shear force. Whatever you got just to left, minus 60 plus 126. Then come to D. Come to just to left of D. Right here, twice calculation. Whatever you got just to right of C, subtract 8 into 3, you get 102 positive. Come to just to right. 102 positive minus 40, 62 positive. Come to B. Again, extreme end. So slightly come inside. Okay, start. Previous value. Plus 62 minus 8 into 4 is plus 30. That's all. Check the answer. If you look right side, downward 30. Shear force, right down is positive. Correct. Nodi. 30. Then, usual statement. Shear force variation. A between A and C, linear. Between C and D, linear. Between D and B, linear. Write the statement here. Then, go back and draw the shearing force diagram. How? By observing these values, draw the shear force diagram. But what you can do is, now you write, jaga illa, VA equal to 202 kilometer. Okay. Now, I'll come little down. Jaga illa, I'll come up here. Okay, now. But actually, if you remember, to draw shear force diagram, none of the calculation required. You take your calculator, start from left hand. Go up by 202. 202. From A to C, come down by 8 into 2. So come down by 16. You will reach 186. Nodi, 202. How much you have to come down? 16 down. 100 ಓ ಇಷ್ಟೇ. That's all. How much it is? 186. Come down by 60. 60. Still you are left with 126. Okay. Then 202. Oh, okay. ಸ್ವಲ್ಪ ಜಾಸ್ತಿ. Okay. ಸ್ವಲ್ಪ. Okay. 126. Then from C to D again come down by 8 into 3 UDL. It will come 102. Not too much more. 102. Then at here come down by 40. Still you are left with how much? Still you left with 60. Half of 126. 62. From here to here come down by 8 into 4. 32. That is still 30 remains there. 30 remains there. Lastly come down by 30. Shear force diagram. Okay. Fully clear? I will go to the next step now. Don't waste of time. In future from next class onwards, such things all I will not explain. Anybody not clear, I will tell start from class number 1. Full clear? Yaro clear and gotagilla. Clear? Okay. Now, those who want important concept, others keep quiet. Tell me. This is linear, this is linear, this is linear. Therefore, tell me, what is slope of this line? What is slope of this line? What is slope of this line? All those 3 lines, they are variation of shear force due to UDL. You know that rate of change of shear force is intensity of load. And also you know that slope of the shear force diagram is intensity of load. From here to here, intensity 8. From here to here, intensity 8. From here to here, intensity 8. For all these 3 lines, slope should be common. Tell how much? Or all those 3 lines should be parallel. See, this is parallel to this one. They should be parallel to each other. Suppose you write randomly. This way, does it look parallel? It looks so ugly. All these 3 are parallel to each other because all of them have same slope. Clear or not? Clear or not? Right. You can check the answer. You can do one thing. You construct a triangle here, construct a triangle here, construct a triangle here, calculate tan theta. I will guarantee for all of them tan theta will come. How much? Nodi? Il nodi. 186 202 minus 186 is this difference. 202 minus 186 divided by 2, 8. 126 minus 102 divided by 3, 8. 62 minus 30 divided by 4 is 8. This is also clear. You can make this note, those who are interested. Okay. Now, shear force diagram over. Right here. Go back and draw shear force diagram. You write, yes. Shear force diagram drawn, all positive. There is no negative shear force here. Okay, now I wrote here. Also, class, I am dictating now something you should write. If you want to seriously learn, you should write now. I'll tell story now. Up to now, after drawing, after finding all the shear force and defining variation, we draw shear force diagram. Then we open our eyes and come and observe shear force diagram. Okay, observe. And check how many points shear force diagram is crossing the baseline. Then wherever it crosses baseline, that is changes sign. It can be a known point or unknown point. If it is a known point, keep quiet. Why? You don't locate a known point. If it is an unknown point, locate it. How to locate? You know it. Why? Because that point where SFD crosses baseline or changes sign, at that point later bending moment is going to be either minimum or maximum. Okay, correct? You write all those statements here. Then write. Now, if you write, if I observe this diagram, like a glass, ಈ ಥರ ಸ್ಪೆಕ್ಸ್ ತಗೊಂಡು ಈ ಥರ ನೋಡಿ, ಭೂತ ಕನ್ನಡಿ, ಮ್ಯಾಗ್ನಿಫೈಯಿಂಗ್ ಗ್ಲಾಸ್ ನೋಡಿ, Can you find anywhere shear post diagram crossing baseline or changing sign? First answer. Can you find any point where shear post diagram crosses the baseline or what? Changes sign or zero shear? No. Therefore, all those things does not exist here. Therefore, you tell shear post diagram, goodbye, I am going. Everything is over. Nothing left out. Simply support beam, so many things are there. None of that here. Nothing is there. Over. Therefore, goodbye. Goodbye to shear post diagram. Tell goodbye. You are completely over. Start. Go for BM calculation. Sagging positive. You write. First you write the BM calculation traditionally. Means ಕನ್ನಡದಲ್ಲಿ ಎಂದಿನಂತೆಯೇ ಹಿಂದಿ ಹಮೇಶಾ ಕಿ ತರಫ್. That is as if you are studying for academic purpose. Start. Bending moment, no clockwise, anti-clockwise. If I tell further, you should leave the class protesting. Why? Sir, what is this? If you still tell, we are feeling what? Insulted. You should tell that way. If you again explain clockwise, anti-clockwise, sagging, hogging, you should tell we are insulting us. Okay, don't tell that way. What to do? Bending moment, sagging positive. Okay, start. You look you write here. Traditional calculation. Look whichever side you want. But one thing, consider only one side. Better consider that side from where calculations are easier. Correct? So, what I have done is, I did the calculation from that side where easier. A, I am looking left side. C also, I am looking left side. But D, I am looking right side. And then B, I am looking right side. Y means my way. A, I will look left side. C, I will look left side. D, I will look right side. B, I will look right side. My choice. So that's how. Then, for a complete understanding, wherever you want, look only one side. But out of curiosity, kutuhala, kannadalli, adhika prasanga, English, not required, just curiosity. Sirf dekhne ke liye. Check from other side. So, or me, if I am looking left side here, or means you should think. Tell me, I decided for A, look this side. So, or means I am looking which side? Tell me. That or means I am looking which side? Unwanted side. All those R's are unwanted. When I decided to look left side. So, when I put or means I am looking which side? Right side. Unwanted. Waste of time. But waste of time later. Today not waste of time. Today for learning purpose. Okay, start. A, I am looking left side. Look this side. Don't tell 0. Because there is a couple here. 914. Right closing bracket. It is no clockwise, anti-clockwise. Negative hogging. Minus 914. Not clear means better leave my class. Study from somewhere where they give more explanation for you. Or where they finish the complete chapter in 2 or 3 classes. Full SFD&BMD, they finish in 4 or 5 classes. Go there. That is the best place for you. If the minus sign is not clear, by this time, after reaching class number 100, I don't know, if the minus sign is not clear, I will tell, if the sign is not clear, for those it is not clear, they are not fit to learn from me. Over. Or, look this side. Full curiosity. Minus 30 into 9. Minus 8 into 9 into 9 by 2. Minus 40 into 5. Minus 60 into 2. Minus, now same answer. See now, I got same answer. Display not visible because light problem. Can you see display? See there? Tell me. Can you see the display? See here. Can you see the display? But first. Can you see display? Minus 914. Can you see or not? Bega. Can you see the answer? No. Can you see the answer? I am holding in the light. Yes. Minus 914. Badappa. One nimisha. I will clear it later. I do not want a stain there. Parvaila. You can manage. Okay. Now, come to see. Look this side. Bending moment. Minus 914 plus 202 into 2 minus 8 into 2 into 2 by 2. I got minus 526 kilonewton meter. Over. Now, out of curiosity, find bending moment here. Looking this side. Bending moment here. Minus 30 into 7. Minus 8 into 7 into 7 by 2 and also minus 40 into 3. It is the calculator. Okay. I won't go near the calculator. I will press here only. I will beg Martini. Yes. It is minus. Oh, same answer. Okay. Then come to D. When you come to D, I want to look right side. Nodi. Tell the answer. Correct. Minus 30 into 4 minus 8 into 4 into 4 by 2. I got minus 184. Out of curiosity, I will look left side. Minus 914 plus 202 into 5 minus 8 into 5 into 5 by 2 minus 60 into 3. ನಾನು ಹಂಗೆ ಮಾಡ್ತೀನಿ. Minus, oh, same answer, see. Minus 184. Start. BM at B. Anybody with a bright idea, I told, when you come to extreme end, consider slightly inside. When you are slightly inside, look this side, nothing is there. 30 into 0. So bending moment directly 0 if you look right side. So at the free end, remember, for a cantilever, shear force will be there only if there is a point load, and bending moment will be there only if there is what? Tell me. At the free end, shear force is there at the free end only if there is a point load. See, shear force is there, 30. And bending moment is there only if there is what? Tell me. Only if there is what? At free end. Bending moment will come by the free end only if there is what? Couple there. By chance, if a couple is here, then BM is there. Otherwise, if point load is not there, shear force is 0. If couple is not there, bending moment equals 0. So many people tell, for a cantilever, fixed end, maximum shear force, maximum BM, free end, shear force, bending moment, both are 0. Wrong. Wrong statement. Under loading case, if bending moment 0, correct. If there is no couple, BM 0. But if point load is there, shear force is there. Okay. Then they will tell shear force just to inside is there and just to outside is 0. Ayo, just to outside what? Where is a section just to outside? Kannadalli, in Gadiya. What? For this building, don't consider next building. Over. Now, see, this is the baseline for bending moment diagram. Point here, A, this is C, this is D, this is B. Oh, I put the baseline here. Usually, see, I put the baseline here, leaving space for upper side, lower side, both. If it simply supports usual loading, I put baseline here because I know full positive comes. And cantilever beam, when you apply only usual loading, whether it is fixed at left end or fixed at right end, under normal load case, everywhere BM will come sagging or hogging. Tell me. For a cantilever, under normal loading case, whether it is cantilever this way or this way, BM will come hogging or sagging. Hogging. So negative, therefore, you do not require any space on the upper side. I can use the full space. Now, see, plot. 0 here. Better mark the maximum first. 914. To some scale, 914. See. I will see how much space available here. Okay, sufficient. 914. Tell me, fully visible? Full visible, ah? Ayyo. ಆಟ ಆಡ್ತಾ ಇದೆ. ಈಗ here I am only obstructing. I should see. I will move this side. Come this side. Somebody is obstructing me. Me only obstructing. Okay. I can go furthermore, correct? Okay. I can go furthermore. 914. Some person long back told me, not now. Sir, wrong, sir. I asked him, how dare you tell wrong? Sir, 202 here, sir. 202 means when there was space problem, I wrote here 914 somewhere here. Someone told, sir, wrong means not that way, sir. Scale problem, sir. What scale problem, sir? 202. 202 means, sir, this is 202. You told so much about scale. He didn't tell me that way. He might have thought that way. This person talked too much about scale. See how foolish he is. He is telling me 202 means 914 will come. 200, 400, 600, 800. I should go below the board. Remember, that is shear force in kilonewton. This is bending moment in kN meter. How you rub? You cannot compare meter with kg. Cloth is measured in meter. Something is measured in kg. How time in hours and minutes. You cannot write distance and see when linear. This is linear, no doubt. Their ordinate is kilonewton, and here kilonewton meter. Then if I write kilonewton millimeter, then I have to go to kilometer down. So you maintain relative scale. Therefore, remember, do not have scale. This is separate, this is separate. Clear? Don't club those two. That is in kilonewton, this is kilonewton meter. Clear or not? This is, you should be careful. If someone tells you, hit back means what? Give fitting reply. Live chat. Okay. Therefore, I will write 914 here. Now see, some people what they do is, I will tell you what they do. See, they write 0 here. Then imagine this much space is there for them. They will write first value blindly, bending moment. How much? They will start. Actually, they will start from here, B. Because usually from there, B at monthly, minus 184. Illi 0. Illi. Minus 184. They will write here. Then next they got, how much? 526. They will write 526 here. And they will write somewhere here, 91. By that time here, they will mark here 914. How would you see? Now, this line and this line, slope will not match. You should be somewhat careful. Respect to mathematics. So, if this is 914, if this is 914 negative, then start. At C, it is 526. 526 is half of 914. ಮೂರುವರೆ ಒಂದು ಸ್ವಲ್ಪ ಜಾಸ್ತಿ. ಓಕೆ, ಇಟ್ಟಿದು 526 and here is ಇಲ್ಲ this is 914. It is little more, somewhat to scale. Okay, now reasonable. Tell me, reasonable now. 526. This is 1 2 250 250 500 750. Okay, now reasonably okay. It is 526. Tell me, reasonably okay. First, full scale not required. Okay, now here D 184. ಇದು 526. ಅದರ ಅರ್ಧ 250 6 3 18. ಇಲ್ಲಿ ನೋಡಿ, this is a midpoint here. 250. Okay, somewhere here. Okay, it is 184. Okay, now join. Tell me, B to D parabola. Parabola can be like this or parabola can be like this? Tell me. First one is correct or second one is correct? Tell me. First one is correct or second one is correct? First one is correct or second one is correct? Parabola. Which one correct? First or second one? First one or second one correct? Today I will explain everything. Cantilever parabola it is. Which one correct? First or second one? Decide madake. One parabola I have drawn this way. Other parabola I have drawn this way. First one correct. Why? Because people know it. Usually when I take a class in a college hall, first time, for a cantilever, I will do one thing. I will put UDL and then draw SFD like this. I will draw BMD like this. You should see the people shouting, no sir. Oh, voice. Why? Sir, not that way, sir. But how? Sir, it is this way. Why? 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 Sir, parabola. This is also parabola only. No, sir, it is like this. How you know it is that way? Damar. Gone. Then I will tell them, do you think I am not knowing it? I know the parabola this way. But you are told so spirit. Sir, no, sir. See the voice raising. Why you raise the voice that much? If you are told, sir, I have doubt or confusion or not clear, you tell that way. Don't find mistake in my class. If you find mistake in my class, you should have enough courage and you should have sufficient points to prove it. When you cannot prove it, don't tell wrong. You don't tell someone that is wrong. If he asks why wrong, if you can't answer, you have no right to tell wrong. You tell not clear. Now, okay. Why? Because here, tell me, as you come this way, see correctly now. Okay, yo, here, it is 5, 184. I told you, 184. Here, see. From here to here, as you come, tell me, shear force increases or decreases? Fast. As you move from B to D, see shear force diagram. Increases or decreases? Fast. If I come this way, shear force increases or decreases? Increases. You know, slope of, these all you have to write yourself only. Slope of bending moment diagram is shear force. Therefore, if I start from there and come here, then slope should increase or decrease. The slope of bending moment diagram should increase or decrease. These all I told earlier. The slope should what? Increase or decrease? Increase. See, if I draw curve this way, see now, here slope is lesser. As you come here, slope becomes more, slope increases. Correct. But by chance, if I draw this way, see here, here slope is maximum. As you come here, slope reduces, slope reduces. That is correct if shear force diagram is what? If it is this way, if the shear force is decreasing. But shear force increasing means slope should increase. So correct diagram is like this. Now clear or not? Correct parabola is like this. See here, same thing here also. Shear force increases. Correct parabola is like this. Shear force increases. Correct parabola like this. Full clear? You should write all these notes yourself. Now, one important concept. So many people, what they do is, see, when they draw bending moment diagram, see, they will think of UDL. Then BMD will be, see, it will come this way. If I draw a tangent here, tell the slope, tell me. If I draw a tangent here, tell the slope there. Here shear force is 0. See, suppose your SFD comes this way. Then if you draw BMD, it will come like this. If I draw a tangent here, tell the slope there. Slope there, 0. That is if there is no shear force. But here, shear force is there. Therefore, here, be careful. It is not like this. See, it is not like this. Not this way. Why? If I draw this way, so many people draw that way without bothering. It is wrong because 0 slope is there. So, Even here also, slight slope is there. How much? 30. When you reach here, 62. Therefore, when you reach here, see now, slight slope is there. Slight slope is there here. Tell me what is the slope here? Tell me. For this diagram, see, slight slope should be there. So when I draw tangent here, tell the slope first. Not shear force diagram. Tell the slope. 30. Make a note. Therefore, what do you do? It is to 184. Therefore, this will have this way. Okay, then from here to here, once again, what? It is parabola. But this parabola and this parabola, this side parabola, tell me the ending slope. Tell me the ending slope here. How much? For this side parabola, the ending slope, how much? Tan theta. What is slope here? Ending slope this side. Ending slope here. 62. Whereas, again parabola will come. So, tell me, for this parabola, starting slope, how much? Starting slope. 62. Sariya nodi alli. For right of the shear force 62. Don't consider point load. When you come further this side, the shear force at the starting of the UDL, when you go inside, S2, 102. Therefore, if for this parabola, if I draw tangent, slope should be 62. For this parabola, if I draw tangent, tell me, slope should be how much? Slope should be how much? This all you have to make a note. I write one thing here. See, before starting. Parabola here, this side slope is how much? Slope, here slope is 0. Right here. Here slope 0. No, not 0. 30. Because point load is there. The shear force is there. Now, here this side slope is 62. But this side slope should be 102. Here. Ending slope should be 126. And again, when you start this side, slope should be 186. And lastly, when you reach here, tell me slope here. When you reach here, tell the slope. When you reach here, tell the slope. At the end point, slope. Very steep it is. It is the steepest of all. Here, steep should come. 202 is the slope. These all you will get correctly only if you maintain correct. See, so many people what they do is they draw this way. See, then they go this way. See how wrong. They will mark higher slope here and lesser slope here. It is complete nonsense. Have you seen or not? They simply mark. See, they mark steep here, then they mark space problem, then they will mark this way. Sometimes people next mark this way. See, shape is okay. So many people have seen online. If I type SFD&BMD there, nowadays my views are, mine also is coming there in between sometimes. I see my channel also, but so many I can see with the lakhs of views. See there, all same thing. How ugly it looks. I am not blaming them. At least now onwards, let them correct. At least I tell them, you are very good views. Sometimes one diagram I saw where 4 or 5 lakhs views are there. But I don't want to tell, it does not contain even 10% of basic concept. Randomly something. Maybe how we got views, I don't know. That was around 2-3 years earlier, because at that time, not much videos were there. So lakhs or 8, 9 lakhs, 10 lakhs views are there, million views. And this way it is drawn. How ugly it is. And simply support beam, see, they will draw BM, shear force diagram comes this way. Bending moment diagram, they will draw this way. See, this is the maximum BM. It should go upper. Sometimes they write this way. What? In Talamela Topia though, they are not maintaining continuity of the slope. That is, everybody, I am not insulting them or not finding mistake in them. My purpose is At least now, let them realize their mistake, give respect to mathematics, give respect to structural engineering, and correct. They need not tell my name. Okay. Someone else, they may ask also, last time you drawn that way, how you change now? Some people are sportive. They may tell, no, one person told. Some will tell, I learned myself. Okay, you learned yourself. I will tell, I also learned from you. Happy now? So remember now, the slope I told. So somewhat reasonable scale is required. Now we are close now. ಎಷ್ಟಿದು ನಾನು 10ನೇ ಬಾರಿ ಬರಿತಾ ಇರೋದು 184. Therefore ನೋಡಿ some slope is there here, then it will be steep, then it will be further steep. See, this slope is 30, this slope is 162. ಅಲ್ಲ ಸ್ವಲ್ಪ ಇಲ್ಲ ನೋ ರಾಂಗ್ ಸಿ ಇಲ್ಲ ಹೋಯ್ತು. ಹಿಂಗೆ ಬಂದರೆ ಹಿಂಗೆ ಟ್ಯಾಂಜೆಂಟ್, ದಿಸ್ ವಿ ಫರ್ದರ್ ಸ್ಟೀಪ್ ನೋಡಿ. ನಾವು ಓಕೆ ಸಿ ದಿಸ್ ಸ್ಲೋಪ್ ಈಸ್ ಹೌ ಮಚ್ ಚೇಂಜ್ ಆಯಿತು. ದಿಸ್ ಸೈಡ್ ಸ್ಲೋಪ್ ಈಸ್ 102, ದಿಸ್ ಸೈಡ್ ಎಂಡಿಂಗ್ ಸ್ಲೋಪ್ ಈಸ್ 126, ಅಗೈನ್ ಸ್ಟಾರ್ಟಿಂಗ್ ಸ್ಲೋಪ್ ಈಸ್ ಸ್ಟೀಪರ್ 186, ಎಂಡಿಂಗ್ ಸ್ಲೋಪ್ ಈಸ್ 202 ನೆಗೆಟಿವ್. ನಾಟ್ ಎಕ್ಸಾಕ್ಟ್ಲಿ ಸ್ಕೇಲ್ ರಿಕ್ವೈರ್ಡ್, ಬಟ್ ಗಿವ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್. One place I not calculate this one, I will calculate fast now. 0. Oh, correct, 0. This is the bending moment theorem. Or what space available here? I will draw one curve now. So the beam will have elastic curve like this. Full beam will hold. And remember, this is fixed end where slope and deflection both are 0. These all you learn in the later. Now I will draw elastic curve this way. Okay, start. This is the 0 slope, 0 deflection, maximum slope. If not visible also no problem. Visible means good. Because not in this chapter. This chapter you don't bother about it. It comes in next chapter. Oh, this takes hours together to open up. Okay, therefore I have drawn the diagram also. Now, concepts are crystal clear. By traditional solution, concepts are crystal clear or not? Because there is a reason for asking. All the concepts are crystal clear. If yes, I want to go further now. Here. Clear. Okay, now make an important note. This is the way you calculate shear force and bending moment and draw the diagram. See, actually very fast you can do, because 0, 30 into 4 minus 8 into 4 into 4 by 2. 30 into 7 minus 8 into 7 into 7 by 2 and 40 into 3 here. If you look this side, 30 into 9, 40 into 5, 60 into 2, 8 into 9 into 9 by 2. You need not find the reaction also. That all I will tell you later. Now do one thing. Now consider real concept. Remember, anybody who want only academic purpose or only to get marks, concept if he does not require, better you go through, but don't worry too much. But those who want a good feeling of the subject, now continue. I will give a small example for you. I will not remove this one. This will be there up to tomorrow. See, this I am not removing. Tomorrow I got a class in the morning time. I will use this side board. I may remove this SFD&BMD statement. I forgot right here. You are right here. SFD, all values are kilonewton, left up, right down positive. This is bending moment diagram. All values are kilonewton meter, sagging positive. I forgot right. You write that way and write it. Now, tomorrow class, I want space here. So, I will take the class on this side. So, I will remove this side. Or I may have to go to a recording today. In case I go for a recording today, I will remove this also. I will write once again before the class tomorrow. Now, see, traditional way is over. One more thing. Class, bending moment diagram drawn. Oh, forgotten. See, some more statement you are right. BMD drawn. Now, after finding bending moment at all the standard points, you also find bending moment at the point where SFD crosses baseline or where SF is 0. No, such point is not there. Therefore, the maximum peak value going up and coming down or going down and coming up, that all not there for the question. So, only standard point calculation will complete the calculations. Clear now? Only standard point calculation will complete the bending moment diagram. That extra point all not there. Clear or not? I forgot. You should write that one. Usually we write. Now also BM at the point where shear force 0, none of them is there. Clear? None of them is there here. No answer. That is a word clear. Clear. Okay. Now understand the concept. The concept is, I'll do one thing now. I first thought I can tell the concept and also finish the calculation today, but already 8:45. No, I will do it tomorrow because even I don't know why. Non-stop talking. I am also feeling a little tired. Okay, now see. Now go for concept based. See, do not see point load UDL UVL. Only important is consider a cantilever fixed at the left end. Tomorrow I will take up the same question where I will tell you concept based or fixed at the right end. Either. Subjected to any random loading. Subjected to any random loading. It can be any type of load. Any random loading. I will tell A here and B here, A here and B here. Remember, if the load is down, there will be upward reaction VA. If the load is down, there is an upward reaction VB. If this will rotate in clockwise direction, a balancing moment MA will come here. Here, this will rotate in the anti-clockwise direction. A balancing moment MB will come here. Tell me, fully clear or not? These two cases. Now time being, fully clear or not? I will tell you what I am explaining. This is not there. Full clear? Okay, now correct way of understanding shear force and bending moment for a cantilever is, see, when you want bending moment here, you look right side. When I want bending moment here, you look left side. If you look left side, 202 into 2 is sagging. Some will wonder, sir, cantilever, how sagging came? No, it is imagination. It is, when you want bending moment here, when you look this side, it is this hogging. This 914 is hogging BM here. When you come here, that much hogging is not there. So, how much extra hogging is there? That 202 into something, that will remove it. It is like negative. See, actually, here BM is this way. It is around how much? 526. If I look this side, it is minus 914. No, to get minus 914, you have to come at A. But here, only this much load will cause bending moment. So, this will give extra bending moment. So, if you want to purchase 90 rupees, what you do is, correctly, you give 50 rupee one note, 40 more required, one 20 rupee note, 20 more required, one 10 rupee note, 10 more required, one 5 rupee note, 5 more required, give 2 rupees note, 1 more required, give 1 rupee. That is the correct procedure. Or you can give 100 rupees. He will give change of, how much, tell me? I forgot how much I told. He will give change of how much? He will give change. See, minus 914 is excess, plus this is a change he is giving. If you want to buy 80 rupees, you give 100 rupees. He will give a change of how much? He will return how much money? He will return how much money to you? No. If you want to buy something of 80 rupees, systematic means 150 rupees note, 120 rupees note, 110 rupees note, 1 5 rupee coin, another 2 rupee coin, 2 rupee coin, and 1 rupee coin. He will give 20. So when you give 100 rupees, someone should not think, hey, it is 100 rupees there. You tell him, no. It is 80 rupees only. He gave me 20 rupees back. Oh, I thought, I saw you giving 100 rupees there. So I thought 100 rupees is the cost. No. He gave me back 20 rupees. You go and see the cost or auto. See the meter. Meter is showing 80 only. Meter is showing 80 for starting point up to here. Therefore, now see, if I take a section here, look this side, or if I take a section here, look this side, unless there is a point load is there, there is no shear force and also no bending moment. Shear force, bending moment, both are zero here. Clear? Here look this side, here look this side. Zero. If point load is there, that much is shear force. Clear now? Fast. Tell yes fast. You tell yes fast. Yes. Yes alladu. ಅದು ಇನ್ನು 20 ಹಳೆಯ ಚೇಂಜ್ ಬಂತು 20 ರೂಪಾಯಿ ಕೊಟ್ಟರು ಅವರು. ಅರ್ಥ ಆಯ್ತಾ? ದೇರ್ ಇಸ್ ನೋ ಶಿಯರ್ ಫೋರ್ಸ್ ಆ್ಯಂಡ್ ಬೆಂಡಿಂಗ್ ಮೊಮೆಂಟ್ ದೇರ್. ಓಕೆ, ನೌ ಡೂ ಒನ್ ಥಿಂಗ್. ಯು ಕಮ್ ಹಿಯರ್. ನೋಡಿ, ಯು ಕಮ್ ಹಿಯರ್. Here you move here this way. Here move this way. Or correct concept is first always consider which one? Tell me. Whether it is this question or this question. Here first consider B. Here first consider A. Correct concept for a cantilever is only once I am telling. First always consider which end? Tell me. First always consider which end? This is the real concept. Free end. Free end. Shear force is zero. Bending moment is zero for distributed load. Of course, if a point load is there, it will have shear force. Leave it now. Okay, start. Now, come here, come here. When you come here, see, this much load will create shearing. And moment of this load will create bending. Shearing will be down here, right side down, for balancing from left side up, and this way will come. It will come. You see that side, don't see this side. See, you write light line. To balance this one, there will be upward force here. To balance this one, there will be this way. That is not required. So this is the shear force BM. Here, if I come here, this is the shear force. Means what? This much load and moment of that load, this is the BM. Balancing badabidi. Artha aita? This much load will create shearing. This moment of this load about, see, this much load will cause shearing and moment of that load will cause bending. Nodi. That much load will cause shearing. Moment of that load will cause bending. Clear or not? First. ಬೇಗ ಹೇಳಬೇಕು. ಕ್ಲಿಯರ್ ಆರ್ ನಾಟ್? ತುಂಬ ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡೋದು ನಾನು. ಲುಕ್ ಆಲ್ವೇಸ್ ಫ್ರೀ ಅಂಡ್ ಸೈಡ್. ರಿಮೆಂಬರ್, ಆಲ್ವೇಸ್ ಲುಕ್ ಫ್ರೀ ಅಂಡ್ ಸೈಡ್. ಕ್ಲಿಯರ್? ಓಕೆ, ನೌ ಯು ಟೇಕ್ ಎ ಸೆಕ್ಷನ್ ಹಿಯರ್. ನೋಡಿ ಇಲ್ಲಿ ಟೇಕ್ ಎ ಸೆಕ್ಷನ್ ಹಿಯರ್. ನೋಡಿ ಈಗ ಇಫ್ ಐ ಟೇಕ್ ಎ ಸೆಕ್ಷನ್ ಹಿಯರ್, ದೆನ್ this much load will create shear. ನೋಡಿ ಏನು ಮಾಡ್ತೀವಿ ನೋಡಿ, ಐ ಆಮ್ ಪುಟಿಂಗ್ ಶಿಯರ್ ಡಾರ್ಕ್ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಜಾಸ್ತಿ. ಆ್ಯಂಡ್ ಮೊಮೆಂಟ್ ಆಫ್ ದಿಸ್ ಲೋಡ್ ವಿಲ್ ಕ್ರಿಯೇಟ್ ಬೆಂಡಿಂಗ್. ನೋಡಿ ಜಾಸ್ತಿ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಟು ಶೋ ದ್ಯಾಟ್ ದಿಸ್ ಈಸ್ ಲೆಸ್ಸರ್, ದಿಸ್ ಈಸ್ ಮೋರ್. ಇಲ್ಲಿ ಇಫ್ ಐ ಕಮ್ ಹಿಯರ್, ದೆನ್ ದಿಸ್ ಮಚ್ ಲೋಡ್ ವಿಲ್ ಕ್ರಿಯೇಟ್ ಶಿಯರ್. ಜಾಸ್ತಿ ಆಯಿತು ಶಿಯರ್ ಫೋರ್ಸ್. ಆ್ಯಂಡ್ ಮೊಮೆಂಟ್ ಆಫ್ ದಿಸ್ ಲೋಡ್ ವಿಲ್ ಕಾಸ್ ಬೆಂಡಿಂಗ್. That is bigger. I don't know. See, as you come this way, shearing also increases, bending also increases. Tell clear or not? ನೀವು ಬರಿಬೇಕು. Thick means bigger value. One more clear required. One more clear required. So that concept it is. Okay, now that way, if you finally come to fixed end, here entire load will give shear. Inna ಜಾಸ್ತಿ ನೋಡಿ ಯಾರು ಅಂತಾರೆ ಇನ್ನ ಜಾಸ್ತಿ ಹಂಗೆ ನೋಡಿ ಇಲ್ಲೂ ಅಷ್ಟೇ. ಇಫ್ ಐ ಕಮ್ ಟು ಫಿಕ್ಸ್ಡ್ ಎಂಡ್ ಎಂಟೈರ್ ಲೋಡ್ ವಿಲ್ ಗಿವ್ ಶಿಯರ್. ಇನ್ನ ಜಾಸ್ತಿ ನೋಡಿ. ಆ್ಯಂಡ್ ಜಾಗ ಇಲ್ಲ, ಅಡ್ಜಸ್ಟ್ ಮಾಡ್ತೀನಿ. ಎಂಟೈರ್ ಲೋಡ್ ವಿಲ್ ಕ್ರಿಯೇಟ್ ಬೆಂಡಿಂಗ್. ನೋಡಿ ಇಲ್ಲಿ ಅಷ್ಟೇ, ಎಂಟೈರ್ ಲೋಡ್ ವಿಲ್ ಕ್ರಿಯೇಟ್ ಬೆಂಡಿಂಗ್. Just understand, 10, just randomly, 40, 80, 15, 35, 110 ಆ ಥರ. ಇಲ್ಲಿ ಬೇಕಾರೆ ಇಲ್ಲಿಗೆ ಸುಮ್ಮನೆ ಎಷ್ಟೊಂದು 8 and 12 ಇಲ್ಲಿಗೆ ಬರ್ತಾ ಶಿಯರ್ ಪೋಸ್ 8 ಅಲ್ಲ, ಸೇ 17, ಇದು ಇನ್ನೂ ಜಾಸ್ತಿ 12 ಬದಲು 46 ಇಲ್ಲಿಗೆ ಬರ್ತಾ. ಟೋಟಲ್ ಲೋಡ್ 17 ಅಲ್ಲ 50, bending moment 148, that way. So remember, as you start from free end and go towards fixed end, nodi, as you start from free end, go towards fixed end, whether right side or left side, no problem, nodi. Then if it is a cantilever this way, as you start from free end and go towards fixed end, you consider free end side. Load will keep on under normal loading. Load will keep on increasing. Moment of the load also will keep on increasing. Therefore, if you have a cantilever here, if you apply some spread loading here from free end to fixed end, as you move, shear force and bending moment both keeps on. What? At the extreme end, free end, bending moment is 0 if couple is not there. Shear force is 0 if point load is not there. Or it is a small value. So as you go towards free end, whether it is this cantilever or this cantilever, as you go towards fixed end, as you go towards fixed end, the shearing effect and bending effect keeps on what? Cumulatively keeps on what? Increasing. Therefore, you can tell under normal case, couples upward load are not considered. ಅದು ಸ್ಪೆಷಲ್ ಕೇಸ್ಗಳು. ಸಿ that is special case. Under normal building load, downward load, then maximum shear force and maximum BM, and I am telling once again, under normal loading condition, someone will tell I can create a problem where maximum BM is not fixed end. I will tell him, you can create one problem, I can create 1 lakh problem with 1 lakh variation. Keep quiet. Not sorry for being so arrogant. If you can create one problem, one case, I can create 1 lakh case. I am telling, for a beam, usually building solve, when you apply load UDL or this way loading pattern, maximum shear force and bending moment right here, you should write from the free end as you go towards fixed end, both will keep on increasing, and finally maximum shear force, maximum BM, both will be at both will be maximum. Nodi, breaking chance, if the maximum shearing chance or bending moment, both will be maximum at both will be maximum at ಯಾವ ಪಾಯಿಂಟ್? ಫಿಕ್ಸ್ಡ್ ಎಂಡ್ ಆರ್ ಫಿಕ್ಸ್ ಸಪೋರ್ಟ್. ಫಿಕ್ಸ್ಡ್ ಎಂಡ್ and fixed end important, not free end, ಅದು ಡಿಫ್ಲೆಕ್ಷನ್ ಬೇರೆ. And also note, for normal cases in building design all, you don't have to worry. If you want maximum shear force for cantilever, all you have to do is is equal to, tell me what? Directly, maximum shear force is equal to, tell one line, total load on the beam. Total load on beam. This will be at fixed end. At fixed end. Total load on beam. Clear? Total load on beam will try to shear here. Will try to shear here. I told, as you come here, total entire load will try to shear here. Here, entire load will try to shear here. And if you want maximum shear force, you don't draw the diagram. Find the total load on the beam, not for simply support beam. Simply support beam load sharing is there. Some load comes here, some load goes there. Cantilever I am telling, maximum shear force is total load on the beam and also maximum bending moment. That also will be at the fixed end. At the fixed end is nothing but moment of what? The moment of entire loading on the beam, loading on beam about which end? Tell me. Don't tell left and right end. Maximum shear force is total load on the beam, maximum bending moment at the fixed end is moment of the entire loading about moment of the entire loading about fixed end. About fixed end. But remember, but with the nature you have to see, under normal case it will be hogging. Shear force sign not required. Therefore, for this question, suppose somebody will ask you what is the design shear force, design bending moment, you do not require diagram. Nodi. No diagram required. Fixed end, 30, 40, 60, 8 into 9. Chapter closed. Maximum shear force. Maximum bending moment. Illi. 30 into 9, 40 into 5, 60 into 2, 8 into 9 into 9 by 2. Hogging. Chapter closed. Clear now? Directly. No calculation, no diagram, nothing. That's what you do in RCC and steel. Tell me clear. Tomorrow I will show you correct calculation of shear force bending moment for this question and one more question where I will start from free end and cumulatively your value you can see keeps on increasing. Clear? Huh? Okay, thank you. Tomorrow class very important. After that one I will take up some few extra examples on cantilever. Then I will ask you some interesting concept questions on cantilever. Or tomorrow I may ask you. Okay. Thank you. Tomorrow, usual time. Hope at least for a cantilever, what all you thought earlier, after this class, knowledge level should be little higher. Agreed? Knowledge level should be little higher now. You should at least have a feeling now. Oh, cantilever is like this. Not blindly find bending and shear force on one side. Okay, thank you.